this lesson, you'll be able to describe the commonly used pressure relief valves, describe the commonly used directional control valves, describe the commonly used flow control valves. The control valves play an important role within a hydraulic system. They are used to control the pressure, direction, and volume of the hydraulic fluid. Without control valves, a hydraulic system would not be able to function and/or would fail from excessive pressure. The location of a control valve in a hydraulic system will help you determine its function. All the valves can be divided into three major types: pressure control, directional control, and flow control. A pressure control valve is used to limit maximum pressure in a hydraulic circuit. Let's look at the two common types of valves used to control pressure: relief valves and the pressure reducing valve. A direct acting relief valve has a ball that is held against a seat by a spring. The spring can be adjusted to relieve excess flow at a specified pressure setting. When oil pressure is equal to the spring tension on port 1, the spring compresses, allowing the fluid to pass from port 1 to port 2 and return to the reservoir. The pressure reducing valve is designed to control the pressure of an individual circuit within the hydraulic system. Fluid is allowed to flow against a valve that is held in place by spring tension. While a pressure relief valve is normally closed, the pressure reducing valve is normally open. When the pressure increases beyond a set limit, the spring will collapse, causing the valve to partially block the flow of fluid. Directional control valves are used to direct fluid flow within a system by opening and closing circuits. They control the direction of movement to a hydraulic actuator or the direction of rotation of a hydraulic motor. Let's look at the three most common directional control valves: check valves, spool valves, and shuttle valves. A check valve is designed to allow fluid to flow only in one direction. This is accomplished by using a check ball that is held in place by either a spring or fluid pressure. When a spring is used, a check valve is also an effective means of pressure control. When fluid enters from the inlet side of a check valve, the check ball will unseat to allow fluid flow. If the fluid enters from the outlet side, the check ball will press against the seat and block the fluid flow. Check valves also are used to maintain system pressure after the equipment has been shut off. The spool directional control valve is common in mobile hydraulics. The spool valve consists of a valve body with passages that are opened and closed with a sliding spool. The valves are designated by the number of positions, number of ports, and how they are actuated. The shuttle valve is used to utilize the circuit with the highest pressure. A ball inside the shuttle valve will shift to the side with the highest inlet pressure and block the side with lower pressure. A flow control valve is designed to control the volume of fluid in a system. The volume of fluid that flows through a system affects the speed at which the work is performed. The more volume that flows through the system, the faster the work is performed. Flow control valves control speed. A pressure compensated flow control valve is designed to regulate a maximum amount of fluid throughout the circuit or circuits regardless of the amount of fluid that is being supplied. A priority flow regulator valve is designed to fulfill the fluid needs of a primary circuit before the excess fluid is allowed to go to the secondary circuit. Flow in excess of that required by the primary circuit bypasses to a secondary circuit at a pressure somewhat below that of the primary circuit. The primary circuit flow is not affected by inlet or outlet pressure. If there is insufficient flow to the primary circuit, then the secondary circuit will not receive any fluid. A flow divider/combiner is a form of a pressure compensated flow control valve that is designed to divide or combine flow to both circuits regardless of load. In the divide mode, the flow is divided from port 3 to ports 2 and 4. In combine mode, the flow is combined from port 2 and 4. The dividing and combining ratios are maintained regardless of pressure.